Okay, so,
Do you know how much more efficient these are, by chance?
depends on what speed it's going in. If it's going high speed, it's no more efficient. But according to the load, if it's turning according to the temperature of the indoor of the room, if I'm near set point, now I'm getting efficient because I'm not gonna go at high speed. I might go low speed because I don't need that much air to get to set point.
I don't think the added cost to the equipment
It's not worth
for
it.
the customer with one of these in there.
Mm-mm.
You will not save enough money by the government mandating this more expensive motor
They're gonna do it
over
anyway.
your lifetime.
Nope, they're gonna do it anyway. And because they're gonna make us do it, and most of the furnaces now are doing it, and have mercy when they mandate compressors to be variable flow. Cause they're getting more and more. If compressors speed up and slow down, I can be a 1.5 or a 3-ton compressor, depending on how fast I pump refrigerant. And then I put an ECM on the condenser, and so therefore, as the load decreases, the compressor slows down, and the motor slows down, and that ends up, it's a very difficult repair, because the cards on those condensers are this big compared to this. Because the more programming and requirement and sensing of temperatures and pressures indoors and outdoors that I require, the bigger card I have to have and devices on the card in order for the machine to carry out the activities we want it to do. More switches.
You know, I have a 16 SEER with the 2-speed compressor, the
Mhm.
Copeland, and I've got a huge board. Do you know that I bought one of those, and it was only $107.
The board?
Yes, I was really surprised, because of
It's huge.
the whole compartment.
Mhm.
No contactor on it either that we have access to, so.
Input, output, that's it.
Yep, power in, power out.
And a LED light that shoots digital numbers to say, here's the hertz, and this is what this means, and so, but this is here to stay for y'all. So you're gonna see, we have one in the lab, the far one, way over there, by the pumps, by the window to the fountain. There's that beige one. That one has ECM, variable refrigerant flow, and sometimes we cover it up.
That has inverter technology.
Mhm.
You know, I also didn't realize that, are all inverter technologies, rotary compressors? Cause that one's a rotary compressor.
Most of them I know are, because they're moving away from recips.
I know, but I mean, we have a scroll.
Yeah,
But,
straw and a screw.
I was just surprised, I was not expecting it to be a rotary. But
Probably carrying all that different load going back and forth, it probably would be best and cheaper of the ones you could put on there. None of that's cheap. That compressor is very expensive. That variable speed,
Yes,
very expensive.
very expensive.
You can buy a Goodman whole condenser for that compressor.
Well, I had to replace my compressor on mine year in, and, the actual cost, if I had to have purchased it, was $1,200.
Yeah. So that's 2,000 plus to the customer for the part.
These
plus
are
the
300 to
install.
400 for our cost.
To the customer, it's about 1,200. All right,
I have a question.
let's share the information with your students. Yeah.
As we get more high tech, will a lot of these parts be kind of like obsolete as time goes on? Or will they pretty much be?
If you mean physical parts that look like that,
Is it more like electronic? More board?
here's the irony to it. I don't care how high tech it gets. What does a switch do? Well, what's high tech about it? Oh, it's not this big. We put it on a card, and we have switches on digital and switches that can be on boards that are not physical switches, but they are switches through bridge circuits, diodes and diodes, that's what they call them. And it can be a non-physical looking analog switch, but it's a switch, because it's still doing what? Open and close, on a smaller footprint. It's a smaller footprint, that's what makes it doable and selling up to another generation, because to be honest, some of the analog material was truly fantastic. Carrier used to make a G5 compressor on chillers. Those compressors could sound like somebody's playing a drum and work 5 more years, and they're already 20 years old. The G5s were a beast. I love G5s. You couldn't even tear it up. Even if you was a new tech and did something wrong, it might get a little loud, but it still worked. Compressors like that. So I said, you guys now are changing to high technology, compressors and motors. You have this real slick motor now, a Biscayne motor. You have all this slick stuff. Motor looks like a, I don't know, man, like a Corvette engine or something. And he said, why did you get rid of the G5s? Weren't making no money, Harrison. I said, why? Couldn't tell one up. He was honest. There was an engineer designer, and he was telling the truth. We couldn't make money. So now, you know, I put chillers in, and they'll tell you now, we get about 15 years off. We used to get 25. And then we change the compressors and get 10 more. So now you have to change it because of the materials that they're made of and the complexity of the circuitry, depending on how many components have failed and how they communicate together, may determine what you want to do with that machine. But true enough, you can make repairs on any situation on a machine. So this, of course, is the base module electronics for a EMC motor. Notice the plug-ins. Everything is plug and play. You'll notice that the wire size to an ECM motor is much smaller than your traditional 120, 240 motors. You'll notice there are many more wires and many more colors, and you have to be careful because sometimes students try to troubleshoot, which they shouldn't. ECM like you would a traditional motor. That is multi-speed through how you wire that speed that you desire to the car, plug it in, whether it's medium, low, or high, yellow, black, white, blue, and orange are some of the speeds, and each color represents a different rotation speed of CFMs. And so these are high-tech. When they first came out, they were made onto the motor. And so you sell that unit, and they had some issues, because maybe in a year, the motor would just blow its cookies. And you go get one then, when the motor costs us $1,400, that ain't good, is it? Because can you imagine telling a customer what that replacement's gonna be? I couldn't hardly open my mouth and say it. I was like, this ain't gonna be a good experience. They say, well, how much is the motor replace cost? And I said, well, you're looking at about $3,300 for a motor, right? Well, true enough, I could buy a furnace of a lesser brand with that motor in it, a different motor in it, and install a whole new furnace for probably $1,700. So I said, this equipment. So Carrier said, hey man, you're not buying any of this. I said, I can't warranty it. Well, we warranty. I warranty free labor. You don't have to be free. It's been there a year. I can't charge anybody that kind of money. That's not good for business. I said, so we stopped buying them because the motors have a fault in them. So then they react quick. They came out with a motor that could be separated, because what you will find out is that most of the time when you say motor, most of the people think about the rotor, stator and that. But most of the time when a motor fails, it's the top part that fails. This part, which is the digital solid state part, didn't fail. But since it was made on, you had to buy the whole motor. So they said, okay, we'll make it separate. So all I have to do is buy this motor for $400, put the end back on it. That's doable on a sale. That's doable. So that's how that came about. ECMs are out there. They're variable speed motors. Variable speed motors are not new in our industry, but it is new, rather new, not really new, maybe 12 years new in residential. The sale is what? You save money by saving energy. You save money. And my question has always been for the last 25 years, what's the payback on that motor? You should watch design engineers get quiet. I said, what's the payback? Well, Mr. Harrison, it depends on how you run it, how you maintain it. If I maintain it wonderful and run it seasonal, what's the payback? Well, it depends on if you live in California, if you live in Arizona, if you live in Miami, or if you live in South Dakota, where it's more wear and tear. Okay, so in the summer, I live in Arizona on the desert. What's the payback? Well, of course, it depends on your utility rates that you pay in your area, how it's defined to the utility company. At the worst, highest out of my pocket, what's the payback? It's difficult to tell until the end of the season and you get this is real, kilowatt usage for your area, and then we get the kilowatt usage that you use with a formula to the cost per kilowatt from where you're from. We can tell you the cost, and then your previous bills that you had to determine what the saving was for old equipment and new equipment, of course with markup over time added in it. How much can I say? How long will it take me to recuperate the extra $1,200 for this motor, $2,000 for that variable speed compressor? Well, it could take, I did my math, it could take 10 to 15 years. Your guarantee now is 10 to 15 years. So I won't get my money back before major breakdowns and replacement time is again. But here's the issue, and then we're gonna move on. So how does this go on? Because sometimes in spoken word, all people hear is saving. Everybody wants to save some money, save. But they never ask what's the payback? How much time? They just want saving, but when you have, I have to say things right, not to be political. When you have regulations and regulatory committees that are looking for ways to save kilowatt usage on a national power grid. California has problems, right? Dallas has problems. They have blackouts because of the power grid. So many people are consuming energy. The power grid, that's what you hear now, has to be upgraded, right? So I have family in California starting January. This is not even believable. It's gonna make people leave California. The power bill went up 57%. So if I paid $300 a month, now I'm paying, what, about $500 a month for the same usage, because the customer is gonna pay for the renovation and replacement and upgrading of the power grid. When it seems like to me, if I'm a power, nobody care what Harrison thinks, but when it seems like to me, when the power companies are a company in business that make billions of dollars, why is the customer paying for your equipment upgrade? Use your billions of dollars. Is it our equipment? It's your equipment. We rent it. We rent the use of your equipment and pay for power to go through your distribution centers. So why am I paying for that? Why am I paying for it? That's Harrison stuff. That's
The
Harrison.
CEO, you really paying for the CEO salary.
Well, not in the CEO don't have no salary, they just have buckets of money, they don't even have to count. Regular people have a salary, if you make money you can't count, you don't have a salary. You, for real, you don't have a salary.
Who
So,
own them companies though?
huh?
Who own those companies?
Power companies are owned by huge corporations.
Not the government?
No, that's regular.
Government stays out of certain entities, because then that becomes government rule over everybody at the cost of the people, so you can control.
I'm gonna look into that.
Form of capitalism.
Government doesn't own
No,
power.
I ain't saying that, I'm just saying for them to charge
That's business.
more money for their product.
That's everything.
Paying for wars.
If Carrier wants to, okay, not wants to, as we update cars, right, and get different models,
The cost is
it is research and development, lots of money. I'm talking about millions of dollars, because that prototype has to be perfect before I can manufacture it and stick it on the street. And it has to pass every EPA regulation and manufacturing regulation it is. So after the product, whether it's electricity, after the product has been approved to go to market, the first thing you do is say, I'm gonna recoup my research money. Prices go up. I gotta recoup my money. I'm not doing it. The customer is gonna pay for the recoup. But the problem is, after you recoup it, it don't ever go back down.
Oh, yeah.
Right, so after COVID, I understood during COVID, it was so difficult
I knew it.
for businesses to get, materials, I get that. And they had to pay more to get a different vendor and all of that, and they was shopping all over the world to get everything, I get it. But after 2 years, you done got your money back. Prices went up,
I knew it.
and they not coming down. That's business. Any bit, if it's hamburgers, that's business.
Yeah.
And then you notice the same conversation occurs, everybody's saying, well, it's very difficult to find supplies. And everybody said, McDonald's, you ain't had no difficult time. Cows was in northern Georgia, what you talking about? You ain't had no difficult time getting a cow to make a hamburger out of. But they jump aboard. The most universal one people know is gasoline for our car. All that fuel in the ground, everywhere. You went up in the 90s, and it never came back down.
About 99, 99.
Now, I don't care if you know my age, but I used to pay 25 cents a gallon.
I remember
I get 4
cents.
people in the car, and I wouldn't let you in my car if you gave me a quarter. So we could ride a half a night for $1. Now I know times changed, because people's salaries were much lower. Food costs lower because there's an inverse relationship to what you make to what we charge you, because if we charge you this and you make this, the food gonna stay on the shelf, because I can't buy it. So as I pay you more, the food goes higher. Everybody protests, man, I'm $17 an hour to work at Kroger. Okay, now the price of food is up. The owner never pays for that. The customer pays for it. Are them people stealing from these stores? The owner don't pay for that. Next time you get some jeans that was $40, they're $82.50. The customer pays for that. That's how everything works. That's why you gotta make so much money to keep some. And you gonna do the same thing. Hey, this motor costs me so much, it costs so much to you, because I have to make a livable wage that's a profit that makes me owning a business worth keeping the doors open. Or it's no sense.
Do you have like people who you shop with for cheaper prices or?
Well, here's the deal. Can I get this motor anywhere? Guess where I have to get it from? What's OEM?
Original
Equipment manufacturer.
Original equipment manufacturer. If I'm Carrier, you gotta get it from me. That's residual income. You bought the unit. If I'm Carrier, you gotta get this from me.
From the carrier.
If I'm Carrier, you gotta get this from me. If I'm Train, if I'm Goodman, if I'm Dayton, whoever I am, Mitsubishi, LG, you have to get it from me. or it won't work. You have to come back to me. So we cut the middle person out with these universal parts. There's still some out there, but it's main known on the equipment. If you use other parts than original manufacturer parts, your warranty no longer exists on your car as well. You gotta come back to me. GM make a different thread on a particular part, but the part is made by the same company that makes that carburetor for everybody. But they make a different thread. So if you put that thread on there, you're gonna strip it. Now you gotta get the whole thing and get it drilled out. That's the manufacturer to seller agreement to keep you in my module of finances for money to go back and forth. If you touch my install and something happens, do I have to warranty it anymore?
No.
Nope, you let somebody else touch it. But I pay, it's not my worry. You let somebody else touch, read the fine print. It's not even fine on mine, read the large print. It's not fine print. If you allow other service companies to service this company while on the warranty is voided. And no mistake about it. No mistake about it. Keep the money in your module. In your module. Okay, so with all that being said, ECM is a motor people don't talk about much, but in this day and era, you need to know about it because, like I said, not only is ECM Motors been out for a while, but even less time for VRF compressors. VRF, variable refrigerant flow, meaning that I can speed it up or I can slow it down, depending on the load. And what is load in air conditioning and heating? This room. This room is the load when speaking of heating and cooling. This room is the load. And so if I want to operate something, since we've been talking so much lately about controls and switches and coils and movement and motion, I have to have a way to control a machine. That's what control class is about. Different ways you're finding out. It could just be click, click, or it could be I have a program in me from the factory that regulates the function in a sequence of operation of how that machine operates. I don't have to do anything. The switches automatically open and close depending on if I'm in cooling, if I'm in heating, and what do we measure most of the time? 3 things. How machines operate. Somebody say it one. Temperature,
time, and
pressure. So depending on the temperature, which we have, what is a temperature as far as electronic? What do we call a temperature measuring device? Thermostat could be, but now thermostats are more than thermostats, and they don't just operate with the old mercury switch or just a boom, 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 opening and closing physical analog switch. It is a thermistor. If I'm measuring temperature, modern thermostats have thermistors in them. They don't even have to be big. They'd be big as that. Because that's, you know they can. Because you have heat sink in your phone, and your phone is that big. So digital circuitry can be very small footprint that delivers a lot of hundreds and hundreds of thousands of responses off of a small footprint. And those responses are referred to as input and output. Phones are just amazingly tasking. Could you imagine the circuitry that's on that little board that you can talk to, that you can hear from, that you can dial if you want to? Tells you temperatures around the world. Imagine that, the circuitry that's on that little board, how minute it is of information. That's what the digital solid state process does for us. Micro circuits, nanocircuits, very small. takes machines to put this together and a machine to put your phone together. Precisely and accurate. And programming for the machine that puts your phone together. And programming for the machine that puts the machine together, that puts the programming into that machine so it operates correctly. We live in that day and age. And I said that so we can understand there's only a certain amount of ports that we can measure on these circuits, and if it's digital, what will we be reading with our meter? What voltage?
24.
And 120 on that?
Digital circuit on a solid state board.
115?
Is it, I guess I didn't say it right, AC or DC?
It's DC.
DC, direct current. The whole purpose of this digital motor is, why did we have to put a trunk on the back of a motor? Didn't you ever wonder that? Why we gotta do that? Because it's a circuit board that's on these digital motors, and if we can use a method, because these motors are gonna have what kind of voltage on a furnace, gas? What kind of voltage?
20 volts.
No, 120.
I said it wrong. Line voltage.
Gas. 240.
Gas furnace.
120.
120. So if we're dealing with digital circuits, we're dealing with, on this particular case, we're dealing with electric sources way less than 24 volts in most cases. That's how we can do it, because we can rectify, we can change an AC circuit through digital electronic response to a DC signal. Now we can control how the motor turns. In a single phase, which is mostly everything residential, and 3-phase is commercial and places people live that are big stars. They don't have houses. They have buildings that look like houses, but they're commercial buildings. They have commercial loads in those places. 3-phase. So we can mimic 3-phase technology by using a rectification of the AC voltage to a digital circuit and make it perform like 3-phase. What does that mean? So 3-phase, I can take 3-phase, L1, L2, and L3, connect it to what we call a VFD, a variable frequency drive. What is frequency? Tell me what each frequency is. Who said that? It's hertz. What is hertz in USA? How many? 60. In other countries in Europe, it is what? 50. That's why you have to carry an adapter when you go there. Or if you're from another place and yours is 50, you have to have an adapter to plug in here. Not really, because now you go click, 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 and you can listen anywhere around the world. You don't need no adapter. So hertz represents the speed of the motor in 3-phase, being that if 60% hertz is the highest, what would 100% look like in terms of speed on a motor? 60 hertz. That's the maximum. If I'm 30 hertz, what am I running? If I'm running 30s, if 60 hertz equals 100%, half speed. So if the motor is 800 CFMs at full speed, if I'm running 30 hertz, I'm running 400 CFM. So I can control the hertz, I can control the output speed and voltage of a motor, and I can control it through DC with an ECM, but I can control it through a variable speed drive, which you'll learn later, with 3-phase power source.
Where did DC come from? Just screen into it?
DC, think of it like a, not really, but think of it to get a beginning understanding of a transformer. How I can take a higher voltage and make it a less voltage. So in this case, we're taking a alternating current voltage, changing how it functions electrically by running it through a DC circuit board, that's a complex board, very small, that changes the AC to a DC. It's common in a lot of electronics now. It's common to convert power from AC to DC. Takes up less room, less heat. Your telephone, less heat. Is your phone AC or DC?
DC.
Is DC?
AC.
AC or DC?
DC.
It's DC.
AC. DC.
It's DC.
DC.
It's running off a battery.
What is it?
DC.
DC.
Yeah, that's right, DC.
Well, tell me this, if it's DC, how can you plug it into AC and charge it?
Oh, it's-
Because the.
'Cause you convert
The
it.
charger is an adapter.
And it's a converter, the adapter is a converter.
mm.
So we use that technology. If a phone was AC, you couldn't hold it for 5 seconds. Remember when older phones, if you listen, you could talk on it and it would heat up.
Yeah.
And then you play videos and it'll heat up. Some of them still heat up because of the amount of usage of power consumption. Using voltage and power consumption creates what? Heat. Heat. And if you have a real complex phone, I don't care how much you paid for it, when it heats up, what's it gonna tell you?
It has to shut down.
I'm hot, you might put it down and get off of it a bit, you know, it wasn't made for you to be a DJ, this is a telephone, put it down. If you get water on it, what happens? Huh? If you have a high-end phone, what that phone gonna tell you? I'm wet, change me. I saw my phone said, I said, what? I went and dropped it in rice. I didn't get but a little water on it. I had to go on YouTube like y'all, shoot. Cause if people smart, they could test the phone and say, you dropped it in the swimming pool. No, I didn't. Yes, you did. Because we have computers that test it. They look like this. Yes, you did. We get this all the time, people trying to get free phones on their little $50 warranty. That doesn't work here, buddy. But we'll take this one back and give you a $2,000 phone for today only. That's your marketing sales for $990. That's a deal, considering that you dropped it in your mother's swimming pool. Put it in when mine got hot, I put it in the freezer. You know how we are, we think we smart, don't we? Well, I'll just put it in the freezer and start looking at movies again. I took it out the freezer, it said, your phone is cold and moist from condensation. I said, what? So how could it do that? In that little phone. We're talking about complex circuitry that can make this motor run at different speeds, make a compressor turn different, make a condenser fan motor, because consolidation in circuitry is the future. It's everything. Everything. You see that big old head sits on, now you go ding. First you had to hook it on your head, like a hula hoop. Everybody, ooh, they have a, wow man, they got a headphone. Ooh, that was cool. Look like a hula hoop. Now then they came out with buds. You just drop it in, you don't need that. Now they even have different ones. Now you can have glasses. Who was talking about that? Glasses, you can do this and play games and everything else. I'm saying this to let you, in your generation, it's common to you. You don't even think nothing about that. Yeah, so we can go skiing on our phone. It should have been better than that. I didn't like the resort they sent me to. I don't like it. And I'll be like, wow, man, what technology? Because when phones came out for me, we did like this, had on with the cord on. And the phone was 15 pounds, the whole phone. It was made out of metal. You kill somebody with a phone. Now you hit somebody with a cell phone, you get ready to get jacked. That's what you get ready to get. They're gonna tell you it didn't hurt, but you will be. So understand what digital, we have a smart valve that has a computer on it. Smart valves didn't last that much in residential because it had a computer card on top of the gas valve. And you know what they did? Anytime we put a program on it, just like on this motor, there's a word we use we're trying to do called modulation. We're trying to modulate it to do higher up and lower. You know what they did within the gas valve? Measure the temperature, measures the surroundings, measured outdoors and indoor, made it report back to the main car. The car reported to the gas valve, and it said, you got a flame this high, and it's only 60 degrees. Modulate that flame. Now I'm still heating the house because I don't need all of that to get to 72. I can get there like this, modulate. But when that car go out, first time I did one, I was kind of hesitant to say if it had burned out. But everything says it's you. But since I never did you before, I don't know it, but it says it's you. And so I went in my refrigeration book right here. I've been in the field a while. I said, I remember seeing that in chapter 31. You find chapter 31 so you can follow me for a second before we do this, because I want you to look at this with a different eye. Chapter 31 is gas heat. As far as I'm concerned, that's one of the best sections in the book.
820, guys.
Mama said 820. And so it should have a valve in here when it gets to the valve. Whoa. That's gonna be saying it is a modular gas valve, since they updated the book. There it is. Here it is.
862.
862. And then you'll start putting all of this that we're saying today together. You may not see one in the field, but you'll remember it like I did. I only saw 2 in my life. And I was thankful that I read my book. And I used to carry that book in my service truck. Tell them I got to go get a part. And I go down to Quick Trip and get me a soda and be reading my book and come back. I ain't gonna let them see me reading no book in their driveway. So I said, that's the gas valve. So now you're gonna see how important this is. And I said, I don't know how to troubleshoot. Does it not tell you how to troubleshoot the harness on that gas valve? What you should read if you plug in. What you should read if you plug in there, and that's how it plugs in. And so I did it just like that. And it said the gas valve wasn't any good. And I said, your gas valve has failed. I turn the TV on, your gas valve has failed. Big old dude, how you know? I said, because we do a certain amount of testing, and through our tests, we can tell with our instrumentation what has failed, and unfortunately, it's failed. He said, is that expensive? So what is it, about $50? You asked me, was it expensive, sir? $50 is affordable. He said, well, how much is this? Honest truth, I checked the gas valve, right? I said, I can't tell nobody that's I get like that. I'm trying to make some money. I said, man, the parts place ain't leaving me no room for me to make no money. You just step up to the counter, 837 Harrison, but we'll let you have it for 800 today. And I'm thinking like, well, so I said, hold on. And I tell the guy the valve is gonna cost you $1,200.46.
Right there.
They always tell me, where the 46 cents? Because that's the total price. I had to pay it, you have to pay it. I always add pennies, because you know, you write them bills, $83, ain't no bill no $83, is it? Once in a while, I'll be like, it's $83.79. And they don't even say nothing. Because you ask me, I have to pay the $79? Yes. Yes. You do? I had to pay it. And so the valve was so expensive, and that was the valve. He said, well, how much? Sometime I'll give you a break, right? So if you say, what is it? And I might give you a break on it, but you have to warranty this. And the valve was 3 years old. So 6% is the add-on for that. And then you better make sure it is the exact valve, because they don't take what back? Electrical parts. You better make sure you read model number and everything is square up. And so before we change the gas valve, what do we have to do first?
Turn off the gas.
Before that,
Turn off the power.
turn off the power to disconnect. And then we have to make sure you have the right pipe wrenches and the gas valve is in what position.
Off.
What does off look like? In line or cross?
Cross.
It's a cross. Just because it's cross doesn't mean that the shut off valve is perfect.
No.
So we can unloosen it a little bit, cause sometimes they leak and you don't want gas coming in someone's house. So sometimes you turn it off and then you have to put a cap on it to make sure. And that's a cap is on the bottom of your drip legs is a cap. That's the end of the line and it's, like a cap on a Coca-Cola bottle where it seals it. It's better be metal, yes, with gas. And then the other thing is we have to remove the gas valve. Sometimes you have to remove the burner, put the gas valve, and you don't crank it real hard. Cause it only has a little bit of thread on it, like this. And you crank it real hard, and then say, I wanna come back a half an inch, and I don't have a half inch, cause it's tight as it can be, and it's facing the inside the furnace, you got a problem. You got a problem. So, you have to be careful and mindful how we put parts on. You have to put, pipe seal on the pipe. You don't put so much on it that it looks like concrete. Some of it's called, Easy Seal, Never Seize, and pipe, liquid, what? They don't call it dope, but I know what you're talking about. Some people call it duck butter in the trade, but it's really Teflon, liquid Teflon.
You have the body caps, or it's already connected to the pipe?
You have to buy them.
You have to buy them?
You have to buy those. And so, but if it was one on the drip leg and it's off at that time while you're putting it on, you could take it off, but I usually keep a couple, 1/2 inch, 3/4, an inch, so that I will have it if I need it. And I can take an appliance out. What if you don't finish it that night? You wanna make sure all gas is isolated. All electrical is secured with wire nuts, either clip the whole end up, wire nut it, tape it, and curl it and strap it to the side where there's no chance for any mistakes or dangerous situation to occur. Put your gas valve on, line it up. The good thing about these is, how do they go back in? Plug. And the plugs are idiot-proof. They only fit one way. Because most of the times, all the plugs that we use in our business look like this. So you can't turn it upside down, you just line it up. And they plug in. Some of them have, how many wires on it? That one has 3, some have 4, they have different shapes. And that's so that we can, as technicians, we don't have to think of all of that. Our plugs often can look like this on the end. You look down there, some of them have different shapes, but some of them, this is a 9-pin, and it's called a 9-pin on that end. What's this end? That's a female, this is a male, this is the end that I was telling you about. See how it's shaped like on the board? You done gave yours away already, too fast. And so,
Looked at it.
okay. Then a little hype. It wasn't that serious. You ain't babysitting right now, you don't have to get that many. Okay, so, we have to be conscious, and what does it say on that tag? That's the other thing I wanted to show you. It has a number on it, doesn't it?
Yeah.
That number, when you buy, these certain cards that have been universal cards, means it can fit with what? Many different kind of furnaces. And it will tell you that a certain furnace will take that number on there, will take that number as a harness. The other one, it takes that number with a harness, the other one. So you have to have the right harness for that board, because they will make many boards for a particular series of furnaces. They'll make many boards. You have to be very conscious, they look alike. Don't those fittings look alike? But guess what those fittings actually do with wires in different positions? Those alignment of harness and plug-ins on a board instructs the board's program on how to work. And so you could put the wrong harness on. They give you all of those in one bag. The one I use is not here because that's the one I put on the furnace. So you may get 5 or 6. And you go on a service call, I put a new board on, I did all this. I said, you throw the paper away? No, it's right there. I look at the paper, look at the harness, look at the harnesses in the bag, take the right one in and plug it on the furnace wall. That's to a service table. Under 50. I just gave him that. He's probably one of my students, that's why I was under 50. I said, you can stop paying me and start reading. You can stop paying me and start reading, as long as you call me. He said, I don't care what it says, I make a lot. I said, keep calling me. I'm gonna make a lot from you. So are we on the same page about how we transfer voltage, either by plug-ins, by placement on the card, also how we change voltage from AC to DC, because we don't stay online now with the ACM motor. But I wanted you to have a little conversation before, so you'll understand that this technology just doesn't roll out on this motor. It rolls out on these boards. It'll roll out on the ICF board, on a gas furnace, 80 or 90, because anytime you have digital, what I want you to know, in solid state, I must have a set of instructions, which is the program, which is the sequence of operation. All we do is learn the sequence of operation given to us in the booklet with the furnace, with the troubleshooting chart, with the LED trouble light explanation, and that's how we service that furnace. Any questions on that? Let's look at this ECM. There's we just showed you that head of it. And what I was talking about with the wires, notice how many, notice how small, and isn't that a lot of wires? And normally you see wires that are larger on traditional motors. You have a plug-in that has to be plugged because we are dealing with different voltages.
Of multi-speed ECM blower motors used for HVAC. This one right here is the X13 blower motor, and on the end you have a motor module. So right here is the motor module. This one is a Broad Ocean ECM blower motor, and on the end you have a motor module, and that's this one right here. And then here's just another version of the Broad Ocean ECM blower motor. Now you notice that the electrical connections are just slightly different. This one just has spade connectors. This one has one large connector on the end, and this one has the connector actually on the motor itself. A quick way to tell if you have an ECM blower motor is if you have both high voltage and low voltage wires connected to the blower motor and you don't have a capacitor. If you have a capacitor, it's connected to a PSE blower motor, and that only has high voltage wires connected to it, and there is no control board on the back, such as this one right here. So an ECM blower motor has a control board module attached to the back of the blower motor.
And does it need a capacitor?
No.
No, it doesn't.
Go over the electrical wiring for a blower motor such as this first, before we get into the troubleshooting.
My friend used to pay $163 for car insurance. Now look how much he pays. Most insurance companies are charging extra. They don't want us to know that there's an easier.
This right here is the electrical connections for the X13 blower motor, and this one's for the Broad Ocean blower motor. So you can see that this tab right here is larger than these three. Well, these three small ones, those are your high voltage taps, and they're going to be hot all the time. The blower motor is not going to turn on until it gets its 24-volt signal wires, and so you have your 24-volt hot wires down here. These are for your speeds, and this one right here is your common for your 24 volts. So this this is not part of your high voltage taps. This is your low voltage common. So these are the same. This one and this one are the same. And usually these are just raised letters, but I put a little Sharpie on them so that you can see the letters and the numbers. So if this was a 120 volt motor, and you'd be able to read that right here on the rating plate. But this one right here, if this is 120 volts, then this is the L for hot and N for neutral or common. And then this is your ground. So that is your high voltage. So this is your hot, that's your common, and this is your ground. If this was 240 volts, and once again, you'd read that right over the rating plate. This will be one of the hots right here on the L, and the other hot will be on the N, and then you just have your ground. Right here is your common for your 24 volts, and you can see that that one's bigger than these. And your speeds are, for your lowest speed is 1, and your highest speed is 5, so you have 24 volt hot signal wires. So this blower motor is only going to turn on when you send 24 volts to the 1, the 2, the 3, the 4, or the 5. So it's only going to be one of these that's going to be hot at a time. And your control board at your furnace or your air handler, that's going to be what's powering the 24 volt signal wire over here to tell this blower motor to turn on. So you're always going to have high voltage to this anytime that the furnace or air handler is on. So this Broad Ocean blower motor has a color code right here, and that's because it doesn't have one large connector for the electrical wiring. So first of all, this is a 120 volt blower motor right there. And up at the top, you see that it's W for neutral. So that's this one right here. And then black is your line voltage for your 120 volt hot. And then your yellow/green, that's your ground, and that's right here. That goes to the ground frame. And then you have your color speeds. So these are your 24 volt speed wires. And first of all, I want to point out that green is your common, so that's not a speed, that's your tap back to the control board. So each of these right here is a hot that's going to come off of the control board to tell this blower motor what speed to run it. So red is your lowest speed, that's number 1. Orange is second from lowest. Blue is medium. Yellow is second from highest, and gray is highest. So this one happens to follow kind of a normal color code, except for that last one's usually black for the highest speed. But you can't go by just the color wires on these ECM blower motors. You need to read the wiring diagram, because a lot of times there are all kinds of various colors. So just be aware of that. So here we have a 240 volt X13 blower motor, and we have our high voltage line right here, our 240 volts, which right now the power is turned off, but normally it's going to always have the power on to this. So you're going to have one is your 120 volt leg, and then your other 120 volt leg, which is going to equal 240 volts, and then your ground wire. So that's what you got right here for your high voltage, which anytime the power's on to an air handler or furnace, this high voltage is going to be hot. Then right here you have our common to this transformer. So what you can do is you can just take alligator clips from the common on the control board to the C terminal, and another alligator clip from the red, and then put that test point on either 1, 2, 3, 4, or 5 in order to test if this blower motor is going to turn on. You can also just have a little test transformer with a plug end, so you can just plug it in. And right now I have a 24 volt fuse that's just a 3 ampere right here, right on the hot. So I'm going to go ahead and turn this on in low speed on the number 1, and then we'll do that again over on the 5. So I just turned the high voltage line on, and now I'm going to turn the low voltage on.
Drinking warm water before bed shrinks swollen prostates overnight, or any type of urinary
What you call it on that vinegar?
So right now it's working, and I have 24 volts on this number 1 terminal, so I'm just going to go ahead and disconnect that. So this blower motor should shut off if this blower motor was good. Anytime you lose your 24 volt signal wires, that blower motor should shut off, but you can see that this one is not shutting off. So in order to shut that off, I had to shut off the high voltage, but now I just go ahead and turn that back on. And right now we don't have 24 volts on the 5, but I'm going to go ahead and turn that on. So you can see it's now spinning. I'm going to turn number 5 off. I'll do that right here at the connection, just so you can visually see it. And that time is shut off. So you can see we're having a problem with your first speed, and it's just not shutting off once we disconnect our 24-volt power. But on our higher speed over here, it is shutting off. So that can be one of the problems if you have a blower motor that just runs continuously. So you want to make sure that if you don't have any 24-volt wire connected right here on the speed taps and it's still running, then you know that the blower motor is bad. And what's really bad is not just this part of the motor, but it's the module on the end of the X13. So this right here is another ECM blower motor, and we have our high voltage is live to this blower motor, and it's waiting for a 24-volt signal. And as you can see right here on our multimeter, we have 27 volts on these two connections. And this particular blower motor got taken out because the module is not telling the motor to go ahead and turn on. So right now we are setting voltage, and we do have our high voltage over here as well, but our motor is just not turning on. So in this case, it's most likely the module, but we can also check the blower motor. A lot of times these X13s, they just come as a whole motor, and make sure that when you are replacing these, that the new motor is set for the particular model number furnace or air handler that you have, and that the correct CFM settings are put into it. So they need to be programmed, and if you do a replacement or rescue ECM blower motor, you need to check the airflow once you install that, because you got to make sure that you're still pushing the correct amount of airflow across the evaporator coil so that the air conditioner doesn't freeze. And so also if you're running a furnace, you want to make sure that the furnace doesn't overheat. So here we have a Broad Ocean ECM blower motor. This is 240 volts, and we have this one wired in just the same manner as the X13. So we have our high voltage, our common, and our 24-volt wire. So now we're going to go ahead and turn this on. So another problem that you could have is that the blower motor ramps up and ramps down, ramps up, ramps down. And normally you're going to be testing this with the blower motor still in the squirrel cage and with the furnace or air handler door still shut. So it's going to be in its normal operating parameters. So it's not going to be like this. But I just want to show you what it sounds like when it ramps up and ramps down. So you can see it's ramping up and ramping down, but once again I have this out of the squirrel cage, so it's going to act a little bit differently than when it is installed in the system. Now I'm going to go ahead and disconnect my 24-volt wire. I'm just going to do it right here. And now the blower motor shut off. So that's actually working when I disconnect the 24-volt power, unlike that X13 we tested earlier. So remember that if the blower motor is ramping up, ramping down, then it's not this part of the blower motor that's bad, it's the control board that's controlling this part of the blower motor. So I'm going to show you what the inside of this looks like. So to take this motor module off, you just have to unscrew this bolt right here and this bolt, and it comes off of right here and right there. Now when you're taking this off, you have to be careful because these connections are still going to be in there, and you kind of have to slip your finger or a screwdriver in there and push in on this in order to slide this connector out. Now on this one, it's a little different. You just have to press on the back. So this is the Broad Ocean blower motor right here. I'll show you what the X13 looks like in a second. So when you disconnect the power to this, you can usually just wait a couple minutes just to make sure that your power is discharged on the inside of this before you go putting your finger in here. But you shut the power off, wait a few minutes, then you can go ahead and disconnect these two bolts and take these two connectors off, and then you have your motor module. So most likely, if there's a problem, this is going to be bad, but I just want to show you what this looks like as well. You have another board right here. On the X13, you don't have this. It's just the module itself, real quick and easy. I would not suggest taking this off and moving it because it's located in a right spot right there. And this is monitoring the rotation of the blower motor. So what you would do is if you're just going to order a new blower motor, and it'll come with the module, and you don't want to take this part out, you can just try replacing this by itself onto this control board and onto the motor and see if that works. If not, then you can take out the entire blower motor and just replace it with your new hub, your new board, and new motor all together. You can just leave it all together just like that. Now in reference to testing this to make sure that this part of the motor is good, I'll just show you what you can do for that. You can test it with resistance. So with your multimeter set to resistance, you're just gonna check each of these connectors right here to ground. You wanna make sure that you're reading OL and that there is no connection to ground. If there was a connection to ground, then that means that the windings are shorted. Then you're gonna check the resistance between each pair. You wanna make sure that your motor is not moving while you're doing this part right here. And you see that we're reading, let's see here, I gotta make sure that our connections are tight. 9.4.
There's one simple vision hack anyone can use to improve vision, so you can say goodbye to your optometrist for good.
9.4. 9.4. Okay. So the actual motor part is good, and it's just the module that's bad. So now we're gonna go ahead and check our X13. And once again, you can just try replacing just the module on the end and seeing if that will fix the motor. If not, I would say replace the entire motor completely. And the other thing that could be happening is in this module right here, you could have one of these capacitors burst. And if that's the case, if the inside has got the fluid on the windings, you want to just replace the whole thing. And you could have some other burnt connectors in here, so you could just do a quick visual check on the inside of the module to see if there's something that's bad or smells burnt in here. So that's something that you can do real quick just to eliminate this as being the problem. You're not really going to be testing points on this control board or on this one in order to determine if these ones are bad. So you just kind of have to do a visual check of this and make sure that this is good in order to tell which part you need to replace. So here we have our X13 blower motor, and we've already taken the screws out of right here and here. We're just going to go ahead and open it up. This one's a little easier. You just go ahead and squeeze that, and you have your motor module. So something real quick to look at is your inrush current limiter right here. If you see that it's bad, you might see a burnt connection right here. Your capacitors could be popped, so
That's a different
that could be an issue. And the one here, I don't know if you can make that out or not,
It
but it
is?
says it's a 20, and this is a 20 or 020. This could be corruption field. You can just cut this out and resolder a new one right back on here. You just gotta make sure.
Ain't nobody I'm gonna tell you something, you can't resolder on those boards, do you know that?
1R020.
You can't resolder on a UL board made by a manufacturer because the
some type of problem could make this
resistance and resistors and components on those boards were made in a factory that was put in negative pressure. The workers work with all these spacesuit-like devices on. It's dust-free, and they are made of exact tolerance. So you can have a 16 ohm with 30% tolerance that might make a radio come on. But you cannot put those on any circuitry that's operating on these boards for machines, because it may interpret that voltage or that device as being not in tolerance range as a difference to how the program works, and that could be deadly. Keep your hands off the board. That's not our deal anyway, is it?
No.
What you gonna do with that board if they need one? Go get one just like it. That's what we do. And he's wrong. You do not change anything on that. I don't care how smart electronically you are. When you change a manufacturer's part, what do you assume?
That is
You
fair.
assume responsibility for
Who
the.
said that? You assume responsibility, and even worse than that, liability. Because you took the original part off and changed it with something else. You keep the liability on the manufacturer. I'm gonna buy the one that you said I buy. You can test it with any testing community or anything else.
This is too bad, but that's what it looks like right here. And you're gonna test this the same way we did with our other motor. You don't see anything monitoring the rotation right here. It's just that module on the end, and you're just gonna make sure that this does not have continuity with the ground frame, and make sure that these three right here, each pair has the same resistance reading. And that's how you make sure that this part of the motor is good. And this is the part of the motor that's usually mounted in there, so you could just switch the hub real quick, but typically we're just replacing the entire thing with these multi-speed ECM blower motors. So I hope this explanation helped. It's real simple to diagnose these. Just put power to it, make sure that you have your high voltage going to it, and then you just go ahead and put your 24 volt power wires on to go ahead and get it to turn on. If it doesn't turn on, and you know you have your line voltage, and you know you have your low voltage, and you know that the motor is bad. So at least the module is bad. If you put power to this and it ramps up or ramps down, ramps up or ramps down, you want to make sure that you have no blockage in your duct. And if you do, and you correct that, and you still have this thing ramping up and ramping down, then the motor module may have got damaged just due to maybe high amperage while it was running and trying to overcome the friction of, say, a dirty filter. If you send your control voltage to this and then you take your control voltage off, and the motor is just continuing to spin, once again, it's your motor module that's bad. Other things that could be bad is just the motor itself, or maybe the bearings. You know, if this has some type of wiggling in there and some movement, or it's frozen, you know, then you know that it's this part and not the module. But typically the module will go bad if this gets locked up, because it's going to start drawing high amperage across the electrical connections inside the module. Be sure to check out our refrigerator charging and service procedures for air conditioning paperback and ebook, both available at our website at eecservicetech.com. We also have our quick
You know it?
I know it.
Strive to keep it 1K.
We need to wake up for 1 second because we all
Sure.
we almost
You know, I ain't want to do that too long.
I gotta wake up.
And then maybe put the logo as on the. You might bring out the tag in the shirt.
For like one the dog pass that's
I got a serious question. Who do y'all think did AC? The person that created it. Oh. Okay, yeah, no. Okay.
Hey, we did it.
You know, and the lady helped them do the heating in the system. They don't let us know that in school, though, is what I'm saying.
Is he the same dude who created refrigerator? We created refrigerator.
I got the picture on my phone. You said who?
Created rock and roll.
Refrigerator.
I do 10 push-ups now.
10 push-ups?
10 push-ups.
Yeah, no.
Not girl push-ups.
I got your backup, whatever which one you gonna do.
Ain't nothing but her to do 10.
3. Yeah, she was in the Navy.
Yeah.
5.
10 push-ups.
She like, it's been a while.
Hold on, I got a picture.
7.
Uh-huh.
8.
9.
One more.
Okay. That's what I'm talking about.
Good shit.
I still want my $5 back.
I bet you can't do 44.
44? Push-ups?
Yeah.
Hell no.
You can't do 44 push-ups?
Not right now.
Who can do 44?
I can do like 30.
Why not?
Huh?
Why not 44?
Me too.
Cause I haven't been working out, so it's gonna I'm gonna start shaking in the last.
It's a shaking.
Yeah, man.
You gonna be like this?
I ain't worked out in over about 2 months.
I'm gonna go tomorrow in the morning.
I don't know.
I did
Oh, right here?
this right here, her had to take a break.
No,
You know,
but we-
bring that bitch forward.
Let me see.
That be getting to me sometimes.
Mm-hmm.
You trying to get your 6-pack? Why
Carter.
they got him up here? He didn't
I know
create
Carter
it.
can do it.
They always, bro.
44?
They got a
He looked at like
44? You can do 44? 44.
44.
44 push-ups.
He young.
Oh, duh. Oh, you gotta
Right
check. You gotta challenge him.
I do eye to eye. I do eye to eye with
He
you.
like,
Yeah, do it.
for $20?
Can you really do it? Or you gonna get tired? Don't embarrass
You
yourself.
can use that for the gas tank.
Yeah.
45.
He said I do.
I do eye to eye with you right now.
Like, you know,
I was
so you
gonna
know you can do the 44.
But imagine Mr. Harrison come there and see you doing push-ups.
Like somebody put it down forever, but it'll be all right.
He finna do it with
40
you.
of these bitches,
No
but this
excuse.
shit gonna hurt me.
You better do them push-ups and get that money.
Let's do it.
This is the type of shit we do.
There we go.
I love it.
Eye to eye though. Eye to eye though.
Eye to eye. Let's go. Sam.
1,
You
2,
going too fast, bro.
3,
You got too damn fast.
Too fast. That don't even
6,
count, bro.
7,
Shit, you still doing them.
10, 11, 12, 13, 14, 15, 16, 17,
Go all the way
18,
down, man.
19, 20, 20, 19, 18, 17, 16, 15, 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Give him his dub, bro.
It's already known.
Carter went too damn fast.
Shaka?
Hey.
Alright, now where the dub at?
8, 7,
Who supposed to give you a dub?
6, 5.
Hey, he went past the 44.
You gotta give him a dub. You won't brought it up.
No,
Excuse me.
yes.
Turn my film room into a nightclub.
More like a gym.
More like a gym.
Listen, we just woke up. Lift every voice, okay?
We're gonna lift every mind.
That's, they just did 44 push-ups.
I don't see that, it might make me tired.
Aw.
Okay, so,
We thought it was break time.
oh, is it?
It's 10:30.
Yeah.
Take your break, that way I can get my quiz stick.
Damn,
man.
C, not at all. D, not giving enough, not enough info.
Right.
Right.
I'm gonna say it one more time.
Yeah.
When the circuits in the drone are energized, the bulb should be eliminated. A, brightly, B, dimly, C, not at all, or D, not enough info.
Is that a series- is that a series
circuit, or is that a parallel? Eliminated.
This looks like a series, ain't it?
That's
Oh, no,
serious.
because
That's a series.
It's
gonna be, it's gonna be dim, it's not gonna be nothing there. It's
Our
gonna be
first
open
line
circuit.
bulbs were dim.
Yeah.
Remember, because that was a series.
We kept, when we were in lab, we kept being green. Some people, I don't know.
So you think
What
it's
y'all
that?
think?
Because the bulbs, different bulbs.
Ain't it bright though?
You take the
At
bulb
this,
out of it, it's not gonna be
If it's,
on.
if it's
well, that's the
parallel.
question. This- But yeah,
It said eliminate.
oh, eliminate
Eliminate a
one?
bulb.
Illuminate.
It's eliminated.
Oh, it is a question.
Is it eliminate or illuminate?
Illuminate.
Light up.
I think they all gonna light up
They all gonna be.
brightly.
But why they was dim when we was in the lab?
Someone
You
said
think
dim.
bright?
I do, because
It's
them
probably
will
the
be.
bulbs. It's probably just bad bulbs.
Yeah, I was
Mine
gonna
was
say.
bright.
As hell.
Ain't your series now?
Your series? Hell,
Yours
nah, they
was
was
dim.
dim.
They were
Yeah,
dim.
mine
Mine
was
was
dim.
Them was dim.
Yeah, your series circuit should be
wasn't as
dim.
bright as the
Mine was dim. I thought so. But they're dim, they're dim.
Yeah.
Because you're putting more.
Well, let's try to do some
It's
hair.
more weight to,
Y'all confused.
series, they separate.
Y'all confused. Somebody go ask us this.
So with more power going.
Hey, you know, don't bring the tears in here.
It ain't gonna be shit if it's like-
That's why I think
My
about
series, it shares. My parallel is more
It's 120, so you 30, 30, and you get 120. On the parallel one. No, I'm just saying.
Y'all, the lights are not just gonna be dim. That has to be the bulb, that light should be bright, right?
I would think it should be right.
Oh, and this is, but he didn't, is the question asking us a series, or is just saying if you eliminate? So it's gonna be dim, right? That's what y'all, everybody say dim?
Number 10.
Yes.
Number 10, when a circuit in the drawing are energized, the bulb should be illuminated. In the series circuit, they won't be.
Told you.
Because
they're all drawn.
They all on the same power.
It's all on the same line.
that means you don't do your job.
whole last file,
Cause if,
And I knew
well,
it.
if you take amp reading, the amp drops.
Yeah, it drops off each one.
I'm gonna redo those labs because you can't buy those light bulbs anymore. You know the filament light bulbs we grew up with?
They don't have them?
That you can see the little squiggly in? They don't make them anymore.
Nah.
Nope, can't buy them. They quit making them. It's outlawed. Why?
Cause they want you to have to color them
What
to
did
get
we talk
everything.
about this
So we have to buy
morning?
more expensive.
Energy.
Cost,
Energy.
last longer.
The energy usage. LEDs don't take it.
So the
Cars-
answer is them.
What are flashlights now? Do they add them bulb? LED. Everything is LED now. Everything is. So one issue I was working a lab to see before I give them to you is that LEDs are so efficient they don't show drops. You put your amp on there, filament bulbs will show that drop. You can see that bulb so dull, and then they would be bright on a parallel. But LEDs don't do it like that. So I'm thinking about putting another relay in there, cause the relay coil would use the same voltage, and you could see a drop between relays. You can see a drop when you put your amp meter on it. But you should also knowing own law, be able to look at the way it's wired and know if it's series. And then you know it has a drop, because it's in series, it would have a drop every time you add a load, because it's sharing the same power source. That's the beauty of parallel circuit. All of us parallel, that's what a ladder diagram is, comes across to a different ladder rung that has our own voltage source, our own power source. So we're not affected by that with one in place.
So it's them. 10 is them.
When the circuit drawing is energized above,
10.
the bulbs,
Or them.
no, they're not. Oh, those are not the bulbs.
It looks like this.
Oh, I see what you're trying to say, it's right here. Yep, they don't, because they're together, they're together. They're them. They're sharing the same L1. Going through one light, the next light, the night, and then what else will happen if you unscrew one
They all
bulb?
go cut off.
So that proves they're sharing the same source.
Okay.
Yep.
So that one is them.
Yeah.
Not
Yeah.
right.
Them. Series, but when my lights wasn't dim like that, when my lights was plugged in series, they were lighting bright. They wasn't just off the
They're not
TV.
gonna change because of the type of bulb it is. That really proves the efficiency of the LED.
I'm like, mine didn't.
That's what it really proves, the LED's efficiency.
Number 11. If either of the two jumper wires were removed, what effect would it have on the operation of the lights in the circuit?
They all cut off.
They all cut off. You just answered. So no bulbs will turn on. Alright. I sent it to the chat too, if you wanna look at the test.
Cool.
Number 12. You gotta look at the diagram for it.
Oh, yeah, okay.
What has to open for the contacts in line 1 to be closed?
That's a different one.
It's in the, it's number 12.
What diagram is that?
I sent it to the.
It's
group chat.
L1, L2. Say it again, the question.
It's on number 12.
What has happened to the CC contacts in line 1 to be closed?
They gotta be hard to, Y and to G.
Look at the diagram.
But power is already
Yeah,
to
the
fan.
CC must be
Diagram.
that.
What you're saying could be true to.
Power is already to fan, guys.
G don't have nothing to do with it.
No, power is
Right.
already going to fan in the diagram. For that one, I picked,
CC energized line.
yeah. That's what I picked too. What y'all think it is? Yeah. I said B, but I could be incorrect. What y'all think? You did? Do, y'all don't think it's, C or A?
I picked B for
So
that.
C.
We said energize and line 9.
No. You said D?
I said D.
B.
Everyone says B.
Okay. Go ahead.
B.
Mhm. This is easy. We all should've got 13 right. And 14. Everybody.
Alright, 13. The primary side, the side of the transformer is being supplied with blank voltage.
240.
E, 80.
240.
C.
Who said E, bro?
40 guys.
Alright, 14. The secondary of the
24.
transformer provides blank.
24.
24.
I know. But he always be here though.
Yeah. Michael Robinson. When the contactor coil is energized in line 9, what lines does it affect in the primary side?
In line 9.
I would say B, 1
and 2.
Condenser fan.
1 and 2.
You said B2? We got 2 for B.
I went B too with them.
B 1 and 2.
Andre?
What y'all go with?
B.
Y'all think B is right? Yeah. We can be wrong then.
When the contact
Yeah, so
is energized in line 9.
I think I did say 1 and 3.
Not line 9 is energized.
Which one are you on?
Yeah, I said 1 and 3.
We're
I
on
said,
number 15.
hold on, y'all. I
You said 1 and 3?
Yeah, I said,
You said the.
A or D. I thought it was A or D.
Okay, number 15. When the contact is energized in line 9, what does it affect on the primary side? Some of us say B, some of us say D.
Compressor and condenser.
CC is compressor.
A and D.
A and D.
So what she talking about? R.
Y'all said 1 and 3. 1 is the compressor and 3 is the evaporator fan. What you think is right?
Yeah, go back to the contactor, remember low voltage is bottom. That's all low voltage. So all of this is the 24 volts on the bottom that energizes relays or contactors. That's what the lower part of the drawing is with 24. When you look at the top, whatever line 9 is CC, you go at the top at 2, and that's what CC is being controlled by line 9. That's the device. Oh, that's how you read a diagram. Remember I said it's kind of difficult when you first start looking at the control at the 24 volts on the bottom, and sometimes you see the same numbers like CC. The bottom represents the 24 volts to the coil, the top represents the contactors.
9 represent 2, right? You just said.
Yeah, it's representing the both of them, 1 and 2, because the condenser, the compressor, and the fan come on at the same time. This is showing a double blade contactor. So when it closes, you said how it worked, but you have to see how it works. You can repair knowing how it works, but it's easier if you look at a drawing and say, line 9, that's the contactor coil, should be If it's CC, I go to CC. CC is the same component for the compressor and the fan, so you know that both of them would run. They don't show, we don't show capacitors, but both of them would run if that, voltage source was running from L1 to L2. These are both sides, L1 and L2. When it closes, L1, L2, T1, T2. When they close, this 230 or 240 volt component will run. It will run.
So the answer was B?
1 and 2.
Because we want to be.
Yeah.
The heating relay, that's the same way, it's gonna be on.
Heating relay is the relay
4
of
and
the
5.
24 volts. Every relay, listen to me, every relay has a coil and a load. So a heating relay is the 24 volts to the coil, to that coil. It's just, on a drawing it looks weird. To the coil, and then the contactors are on the line side, upwards. That's the line side. So and drawings are like that to show you what is controlling the closing. You could go to a machine and say, click, I got 24 volts, it's closing, it's running. But where did the voltage come? So you know it came from inside, didn't it? On the air handler furnace part, because that's where the transformer is. And then it went to what? What is the switch to hold the power back till you want it on a coil? That's the coil. See the stat? The stat is controlling what voltage goes to the coil, whether it's open or closed. If they show that on G, then what's gonna run? What fan? Look at G and go across 8, what fan?
Evaporator.
Evaporator fan. Coil will be energized. When the coil is energized, the voltage to that component, EFR is evaporator fan motor, will close. It will close. When it closes, the fan comes on. And when the fan comes on, according to here, it's 240. And so it kind of looks like a, where they have the 4 with the, where they have the relay and the heating relay, because anytime if you run electric heat, the fan must run. You must have airflow across a coil of heat, resistance. That's what electric heat is. It's a coil of resistance. Are you sure of that? Familiar with that? It's a coil of resistance. So if we don't have airflow across the coil of resistance as far as heating is concerned, the limit on the electric heat will open so that you don't destroy and sag the electric strip heat. They will sag. So they have a safety in it. They're not showing all those safeties. So this is a good building block of how you read it, because on a lot of wiring diagrams now they keep numbers over here. You say, okay, number 5 goes to heat relay. Let me go find the heat relay. Let me go find the heater. Okay, I got that. What controls it? What controls this? You're getting better at it. What controls this? When we say control, what makes this energize and de-energize? Come on and off. What?
24 volts.
24 volts. And 24 volts, if you follow it all back, it makes you understand it. 24 volts, you get tired of me saying it comes from where?
Transformer.
Transformer. Thermostat is a switch. What kind of switch?
A temperature switch.
It's a thermal temperature switch. So if we turn it on, then you have, depending on the thermostat, do you have punch numbers to raise temperatures or lower temperatures? Those are settings. The electronics in the thermostat responds to the settings of when switches will open and close. It responds to the settings. So it doesn't seem so difficult when you trace a circuit, and I would recommend, so you totally start getting it, is because of the first question is, I can't have 24 if I don't have what? There you go. But it could look like, this is some neat stuff too. a non-24 volt service to a piece of equipment could be, name me something that you know it could be. A non-working 24 volt system, when you read, could be a symptom of what?
No power.
No power. It's not always a failed component. No power, Nate says, no power resembles failed primary contactor, not contactor, transformer, because there's no transfer of power or voltage going. So they ask you all these complex questions, then they get real simple. And you're like, what? Of course, if the switch is off, we don't have, but sometimes that's the answer. So I'm doing it to show you where it comes from. I have to have the service switch by the furnace on. Power must come, or voltage must come from the breaker center. Then it comes to the service disconnect. After the disconnect, it goes where? Everybody says that too. Because it seems right though, doesn't it? It seems like it would go to this board, or doesn't it? But it doesn't, because it's another safety that's so basic we don't even think about it. The door switch has a button. Because when you take off the door, do you want to stick your hand in there and that motor run? Nope. I don't. You might want to. You might like that. But it shuts the motor off for safety. Then, because it just takes that 120, if that's the gas furnace type, 120 breaks the 120, takes it to the board. When the board gets, in this case, 120, that's a 240 circuit, but when the board gets 120, then all components on the board that needs 120, it'll have a neutral and a line voltage, and now the board is energized with 120. It's energized. And it has spades that you plug in, all line side and a neutral bar, which is that blue. All your neutrals go there on that bar. All your neutrals go there. So that puts 120 on this board. You have a plug-in. That harness goes to other components, so you don't have to keep sticking individual wires. Put the wires in a harness, plug the harness in, and all of these go where they're supposed to go just by plugging them on a spade clip. So now that we have the 120 here, we also have 120 that's serving the primary of the transformer. If I serve the primary, what do I expect to have secondary? Now I have the 24 where you started. If I have 24 there, I can also assure that 24 is on the terminals of R, Y, G, and C, and W. Right there. It's there. And from here, which is a power exchange, to the thermostat. Thermostat is a switch of the power we send, or the voltage we send from the card. Yes.
Earlier, did you say 120 comes into the
120 on this particular, looking at the drawing, is usually if a circuit on the drawing, and it told us it was 240, so this one, looking at it, it's on the outdoor unit, except it has that heater on there, which says evaporator fan, and some of these circuits are on there, but they're not in that same component. But electric heat would have 240 on a heat pump.
coming into the board?
240 coming off of L1 and L2.
Okay.
But it will run, here's the strange part, it will run off of 208.
Okay.
But to your question about voltage drop, this is where that comes in. If the system has maximum output of heat at 240, and even though it can run at 208 and 240, then will I have the same amount of heat?
No.
So when we start talking about voltage drops, because it's not the same put in, and it can't produce it. So you're gonna have less heat performance even if it runs. So if I'm doing a heat pump and I put L1 and L2 and I have 208, you're not gonna get no heat out of that heater. That's 208. You're not gonna get it.
I just wanna make sure, 'cause I remember you telling us only 24 comes into the board. Does 120 come into the board? Is that what I
Okay,
understand?
so are we talking about the board on the furnace itself or the board outside or what?
On the furnace.
Okay, so if this is a gas furnace, it's gonna be 120 in residential.
Okay.
120 comes in from the service disconnect switch to the door switch to the card. So that's just saying, I can check the door switch, or I can just check on here where line comes in, L1, and I can go to neutral on this bar, and if I go there, I should get what? L1 to that neutral, what should I read on the 120 circuit?
120.
120, so you can test it right off the board. This 120 is testable. That's all that's saying. So the board has to have, the voltage that is required in design in order to power up components like fans and be able to work with relays and contactors. It's the inside source and the outside source. And I don't think we talked about it that way before, inside source of components with components and an outside source with components. But you see them both on the drawing, but they're not in the same location. So some is talking about the condenser, some is talking about the evaporator and a fan relay. So you still have to know the components to where they're located. Even though on the drawing, it just shows them all there. It's showing you how they connect, but it doesn't say that's where it's located. So part of what our technical job is to know where certain components. If we say evaporator, where's it located?
In the furnace.
You said evaporator? Oh, my bad.
It's inside.
On the furnace, at the top.
Okay, make it good. So a fan relay, if it's an evaporator, EFR, that's evaporator fan relay. The point I'm getting to, if it's talking about evaporator in residential, is that component inside or outside?
Inside.
It's inside, so all my troubleshooting is gonna be inside. The cool thing about inside components is we're at the card and everything, I'm right there where it is. Evaporator fan, power supply, line voltage, secondary voltage, all here. So, sir, if I had this card with those terminals and I wanted just to make the fan run, what would I jump?
Yeah, the power and.
You don't push the 16.
What? Well, he asked the question.
I know, but we
Well,
trying
he asked it. Where you 16 at?
It's in
Nah, I can't read that.
We on question 16.
R and G. And the fan should come on. If the fan comes on, you automatically, this is how you're gonna troubleshoot. You automatically know you got 24 volts, so the fan wouldn't come on because the relay closed. It wasn't running before you jumped out R and G. So the relay did close with the 24 volts at the bottom of that drawing. It did close. Because when the relay closed, the relay closed when it was, when the fan coil received 24 volts and the motor ran. That's the logic. And what's you say, what number?
16.
16, a voltage
We
reading
should all get this right,
from
everybody in here.
L2 to ground in the above schematic, which is 240. From L1 to L2 should be what? 120.
No, it says a voltage reading taken from L2 to ground. L2 to ground, right?
Yeah.
L1 and L2.
Yeah, that's 16.
20 questions. Did you already have a lesson for us after this, or should we finish that?
A voltage reading from L1.
To ground.
Yeah, L2
Okay.
is 240 in this one.
L1 to L2 is 240 volts, right?
Yep, L2 to ground.
If I have a ground from either side, if I take my meter and go from L1 to ground, what will I get? 120.
So the answer is B. 16 is B.
15 was B, right? Line 1 and 2?
Yeah.
And the same thing if I go to the other one, to ground. As a matter of fact, that's one way you can test. If I have a 240 circuit and I go from here and here to get 120, and I go from here to ground and get nothing, what leg is messed up?
L1.
Line 1. That's the way you can test it. And then we already know if we go here, it should be 240, but we want to know which leg has died. Bam, bam, 120. Bam, bam, 0. It's you, buddy. And it could be you on a double contactor.
Well, I'm confused with what you did. You did this one and this one.
Yes, L2 to ground.
That's to the ground. You did 120.
120.
The same thing for this side.
120 if it's good. But if both of these read 120 together, it's 240.
It's 120 to both sides.
Yeah, that's 240.
And you still can use the black and the red meter.
Yeah. Yep, that's how you do it. And so that way you can tell if I have 240 here, all that's telling me I'm good from the circuit breaker. I'm good, cause I got my 240. But if the machine didn't run, when the coil closed on 24 volts, I could go here to ground, I'm good. Here to ground, I'm not. I don't have enough voltage to run the machine.
Where's that on one of these? L1 and L2?
L1 and L2 is here and here.
So the ground.
L1, L2.
So you do one L1 and then the ground.
Yep.
But the ground's gonna be on the front.
Case ground, it could be a case ground, put it on the metal of the machine, and it should read 120. And we'll do it in the lab one day.
17.
Number what? 17, in the schematic drawing, which of the wires in a thermostat is the power
We
wire?
all should've got that right.
R, that's C.
C. You say C. C. Yeah.
18,
C.
which of the wires in a thermostat when closed R will cause the fan to run? If that relay closes. D. So all this is doing is seeing, do you know how to look at a drawing and tell which part is low voltage? Do you know how to look at a drawing and tell which one is line voltage? Do you know the terminals on a thermostat to know if we jumped them out and pretend we was a thermostat, which part of the system would run? Number 19, what is the voltage applied? All of the loads in the primary. Primary is, what primary is, 240. That's what the primary is. That's the primary. 20, what terminals in a thermostat have to be closed to cause the heat and relay coil to energize?
B.
Yeah, why is R and B?
Yeah, but why is cool?
Why is cool? He said cool, that's it.
Which one it say?
R to W.
Power to heat, right?
Yeah,
R to W. B.
it's kinda, for the coil it's 24 volts. It's always 24 volts for the coil. Always. Twenty.
12, 21.
21, to eliminate a possible thermostat problem, which terminals could be jumped together to bring on evaporator fan, condensing fan, and compressor?
Which one jumps together? Yeah, what y'all think it
Evaporator
is?
fan, we know that's G. Condenser fan is gonna be, and compressor will be what? Why? Because they both come on at the same time. So what would be the terminals?
R, G, and Y.
There you go.
D.
D. Mhm. 22, a 120 volt single phase motor is being supplied with 120 volts. Okay, sounds good, but has no amp draw when checked, and amps read 0. What should be expected?
It don't work.
Long fuse or trip breaker?
You said it's no amperage?
No amperage means the motor's not running. I have to have a load in order to draw amperage, to check amperage. So it's not running. So there is no amperage. It has to run in order to have amperage.
I think it's B. You said the motor not running.
Hey,
It has no amp draw and an amp meaning of 0.
You said D?
What should be
They
expected?
said, some of us said B, some of us said D.
He said A.
Chef said, hey, why you out there smiling?
So, one thing they didn't say to me is that,
Yeah, he said it's an
the question didn't address was there 24 volts on the coil? Was the coil closed and the motor didn't run?
right.
Or was the coil not
They
energized?
didn't elaborate.
So not enough information.
And so that's what I was looking at. I said, if the motor wasn't, if the coil wasn't energized, it is not gonna run. So I don't too much say blown fuse, cause most of the time now it's breakers. We know it's not shorted to ground
Yes, he was out.
because the
So,
breaker,
A
it
or B?
could be a trip breaker.
Okay.
It could be, if it was shorted to ground. See how stupid this stuff is sometimes? If it was shorted to ground, it could be a trip breaker. It could be. I think too much. It could be. And,
Open winding? It could be
open
that too?
winding, it wouldn't run either. So sometimes I don't know if they're really being simple, real simple and basic, or if they're really trying to get me to think, because I'll look at it and say, could be a trip breaker. Same thing as a blown fuse, but a blown fuse is not, because a blown fuse would be a result. Blown fuse, trip breaker, and if it was shorted to ground, would have the same effect to the breaker being open and the fuse being open.
You in timeout?
What is it, A or D?
It could be an open winding. It could be an open
So A or
winding.
D could be right, but one gotta be right. One answer is right.
Not necessarily. We make errors when we.
But it has no amp draw.
On the test though, we still need one answer.
Because it makes it kind of cray-cray, because it says 120 volts on a single phase motor, that means nothing, but it has no amp draw, because that means right off the bat, it's not running, it's checked. So, and amp meter shows, I just saw something, 0 amp draw, what should be expected, so. I would say open winding, because when you tell me when checked, right? That means you energized in my brain. You said when checked, how I'm gonna check? I had to energize.
Well, it said it had power to the motor.
So it has
Puts
power
an
to
amp
the
draw on
motor.
it.
and
No
it's-
amp draw,
It's
so.
open.
Okay.
As long as you got power, if you got power to it,
That was the.
if it was shorted, it would normally trip a breaker.
It was a trip question though. It had two answers that could have been. correct.
Well, when they said, I saw it that way until they said, when checked. And my brain said, if you asked me to check it, I energized it. And it didn't run. In my brain, it says the fan relay closed,
Okay.
but it didn't run.
So 22 is D.
That's what I'm saying is.
People also say that somebody else said that should have you blown before you got there. How do you know if they checked it?
23 is D.
You don't, you're gonna
You
check
don't
it.
know, but he said,
I said B.
here's why I say that. No, it's okay. It's a baby duck. So here's what I'm saying. Even if the fuse was blown and I checked it, that means I replaced it. And then I energized it, that the coil was energized and closed and nothing ran. Cause why would
The key
you say
is-
I checked it?
It says it has 120 volts to the motor,
How
so
is
that
it?
would eliminate the fuse, because the fuse would blow before the motor, so you wouldn't have power coming.
Okay.
Okay.
Yeah, that's why he's trying to drill that in our brain.
Well, the issue is on this, you sometimes, when you read the question, you don't, it doesn't go in your brain correctly. So sometimes you have to really read it very carefully. In this case, it does say that it had 120
Check.
coming to it.
And you checked it.
He said he haven't decided.
And when you checked it, what did I say when you checked? What is
About to be
next?
gone too,
You
right?
have an
You're about to be
expectation
gone
that
too, right?
something's happened. So if I had 120, my expectation on a relay would be what? That the motor ran. That's how you troubleshoot. I have what I should have, what's my expectation now?
That has better back.
Okay, a circuit that each of the loads share voltage and none of the loads receive full voltage is what? Series. See, 24, switches and safeties are wired in what? Yeah.
Now, we say that, but with the new stuff in the board, technically, the sensors will go back to the board. Now, with the old 60%ers, everything was physically in series.
But now it's both.
It can be. Because if each sensor goes back directly to the board, then the board, technically they're wired in series within the board. If any of those open, they will cut.
Are you marking the right answers on there? Yes, I'm ready.
Series.
We're on 25.
A device that consumes energy and converts it to a mechanical motion or magnetic field is what?
B, what's that? B.
B.
What you, is we wrong or right?
B.
Okay. 26.
A set of contact like the one shown, okay, supplied with 24 volts. When a voltage reading is taken from one side to the other and the reading is 10 volts is read, what does this indicate?
B.
B.
B. Okay. That's kind of like a Nate question too. It is on Nate Gas. They ask it too, they'll say contacts. Nate says that the contacts have failed. Because if you get 10 volts, it could be, according to Nate, if you looked at it from the side, contacts should be what? Closed, right? And so and they should be smooth. Real smooth, like glass.
That would be called voltage drop.
And what was you
Too
talking
much
about earlier?
resistance.
Voltage drop. And so here you go. This is what it looks like. Why it does that is that, you know what arcing is? It's like welding, and it can spark, and sometime in our business, we call it a rattling relay. And it creates sparks. Those sparks create welding, and it does this. It pulls the metal off. These are tiny contactors. So now they're touching by the teeth, little burnt welded metal, and you're gonna read 10 because you don't have a full contact. You have a piece of a contact.
So
you want
is
it to
B?
be like this. Yes. The switch shown to operate, operates in, that switch, operates the following way is what? The switch to the left, that symbol.
I don't think the answer is on here. I think the answer is closed.
It's not temperature, A and C is out.
It is D. It's a pressure switch that's normally closed. It opens on a rise of pressure. That's what it does.
Can you explain that though, because I thought it was a fall.
If it is, well, first of all, you have to look at the switch. That's mainly why we look at it. I can see that.
If you can't see the switch diagram that shows its unenergized position, then you don't know whether it's gonna close on a rise or.
Open.
So if it's down below,
I didn't do that.
it'll close on a rise. If it's showing up above it, then it's gonna close on a drop.
Okay.
Yeah.
But you have to be able to see the symbol.
Can you explain that?
Say it again. Yeah, say it one more time.
Just explain that again.
Cause we gotta be clear. That was that question from earlier. If it's up, yeah, it's gonna be stuck.
Okay, so if it's up like this, that's gonna close.
On the rise.
No.
On the ball.
That's its unenergized or normal position, so it's gonna close when this drops. If it's down here, then it's gonna close on a rise.
Well,
And the little
this
ball
is
will be a
gonna
buzzer.
open.
Yeah.
The one that you drew first is open, right, correct?
Yeah, they're all open initially.
So when it gets too cold, then the top one is gonna close.
Yeah, let's say this with a pressure switch, pressure drops, it's gonna close the switch. Yeah.
Okay.
So that is closed on,
This is gonna close on a decrease.
on the
Ball.
rise,
This
No.
one will close on a rise.
decreases when it go up.
Yes,
And when it go down, it's gonna open.
yes.
Okay.
So
Can you
again,
write it on the side?
It depends.
This is what they have, right?
Oh, they do? Okay, they actually are showing the picture. Okay, well, let's do it that way.
You go pressure, not temperature.
It's not showing what this
Pressure
is.
and
No,
temperature share a
pressure,
relationship.
temperature, yeah, but they different.
Well, he's doing something totally different.
He's telling us that, like, it's, what it is.
Okay, here's your pressure switch down here, the pressure part of it. So this is showing that it's touching now.
Yeah.
And that's gonna be unenergized. So this one, if the pressure increases, it's going to rise and open. Cause it's already, now if it were touching down here, then it would be a drop.
I told you that, but I know.
He said it's,
Hey,
that's not.
look at me. I know why you
This-
asked.
Everything we're
I'll be
showing
messing
is
with
the
people. I'm messing with
unenergized
people.
position.
No, I'm messing with people. I'm just messing with you.
So any wire diagram shows everything unenergized.
Lazy,
How is that unenergized if
I
it's?
believe.
So 28 is open.
Yeah, how's it unenergized if it's touching?
How is it unenergized if it's open?
If it's touching.
It's not, it's touching, it's in line.
Well, that's its normal unenergized position.
No, 27 is D.
Oh.
Yeah.
27
Oh,
is
So
D.
if it's
switch.
already down, if it's above the
A
dot,
switch will say,
it's on a rise, if it's below the dot, it's on a decrease.
a switch will say
And if it's
NO or
open to
or
begin with,
NC.
then it'll have to-
Normally
But if
open
it's
or
already
normally
closed, it's
closed.
unenergized.
That's how switches are.
A safety is unenergized is closed.
Okay.
Cause we want power to pass, it's only if it's out of parameters that it'll open.
High pressure is safety. High pressure switch is for protection. It opens when pressure exceeds the value, the
So
limit.
28 is C.
Yes.
Okay.
But yes, without seeing the picture of the switch they're showing you, you
No,
would
he
not,
told you what?
wouldn't be able to answer it. Cause you
You're
wouldn't
not
know.
listening. Don't hurt him. What'd he say?
He said it's gonna drop on the bottom. If
If
it's
it's
above it,
open
it's
like
gonna
this.
drop. If it's
Mhm.
below, it's gonna rise.
6 months.
Yeah, what are you confused?
If the line, if the ball is below, if the ball is below the line, it rises.
That's right.
If the ball is above the line, it
It
drops.
It's gonna drop. That's what we're talking about.
L1 and L2 of a line voltage schematic is called?
I never heard it called none of that.
It's a ladder.
Yeah, it's a ladder. I didn't know that.
Me either, I said D.
I said, where you find that at? I said C.
I know what I said.
How you know that?
Because I mean, that's the way that's what they call
You
it.
talking about like ladders
It
like
looks
this?
like a ladder.
Yeah.
You got your
L1,
power
L1,
on the side,
L2,
you got the
L2.
lines going across.
Yeah,
And
and
the bar
it-
on the
That's
ladder.
what y'all call it though? They never told us ladder.
did
this
say
and
that.
that.
Ladder.
Ladder diagram.
That's in the book.
It's in the book, and it's on this.
I got this.
What it say in the left-hand corner at the top? What kind of diagram?
Ladder.
Okay.
Okay. I got that
Now,
one
most
wrong.
wiring diagrams on our units give us a ladder and a pictorial. So it gives us two.
Oh,
So if you like one as
it
opposed to the other style,
Damn.
you can use either one.
did talk about it.
Cause pictorial doesn't have wires to it a lot. It shows the placement of a control.
They're different.
The ladder shows you the wire connections of a control. But if you walk to a unit, it could have a whole lot of components, and you might look at it, this is why it's like, you might say, what the heck is that?
Now-
So you look at the pictorial and say, oh.
Now, if you see
Go
this
find it.
right here, the third line up, you got a high pressure, it's on top of the line,
Yes.
and then you got the low pressure, it's
So
on.
that's on the rise and that's on the
So the
fall.
high pressure will rise to open, and the low pressure
On
will
the fall.
fall to open.
Bed.
But they
13.
normally close.
This is showing, everything on here is with no power.
Would you say also that those normally close?
Your safeties will be normally closed,
Okay.
because we want to pass power unless there's a leak, then they open.
Alright.
And if you go up a little bit higher, this next one is temperature.
Yeah.
Number 30. How many loads are allowed on each line of a schematic?
Unlimited.
I said B
Unlimited.
because you explained that.
Unlimited.
You
Never
said it.
know.
Yeah, you said.
It's gonna depend on the amperage you're using, cause it's gonna change according to the load.
Yeah.
But you can go on and on and on. Okay. But where's the lines they're talking about on the drawing? A safety normally,
Damn, now that we talking about it, I'm like, I got simple 31.
okay. A contactor coil,
Is
which
big.
when on has a reading of OL, what does that mean?
Big.
Open coil? Open.
Open line. I mean,
Open winding, right?
what is OL?
Open up.
Overload.
31 is B.
Actually, it stands for open lead. Lead wire. Only reason I know that, cause I won a $400 meter at Minodorf's, where they were giving it away, and they asked everybody, what's OL? Overload.
Overload.
Open line.
And I said open lead, and that's what it is. You see? Yeah.
You also will hear it as infinity.
Only reason I got it right, cause I teach it, I read it all the time. Everybody in the room was an HVAC person, and they weren't no rookies.
So it's A.
And I say this every day, I know.
So it's 31A?
Yeah.
We don't always use it right now.
No,
It's B.
it's OL. If you read ohms and it's OL, it has what? It doesn't have continuity, cause it's OL. It has an open winding. It has an open winding.
B. 32. We sure I got this right too.
Which of the following would be considered a good conductor? Glass, copper, rubber, or air?
B.
Alright.
Okay, let us get this one. Don't tell us.
What is-
Read the question.
What is the job of a symbol if it is labeled FS and is series with the normally closed contacts of a fan relay switch and the fan motor?
C. I don't know.
Hold on, wait a minute.
No, hold on, wait, let's think about it. The question.
You can almost always
Gotta be
eliminate
temperature.
two, cause they're not even remotely close to the question.
It
And
has
you
to be
get-
temperature.
Then you got a 50-50 guess, you get it right.
It said it closed the contacts.
I think
Which one, which letter is that?
Those are good, those plastic
C?
chips.
Gotta be C.
Yeah.
To close on a rise in heat to energize the fan, that's a C.
500 on C.
It says if it closed and for the relay switch and the fan motor.
That's right, if it's a temperature switch and two ask questions about pressure, well, guess what?
Yeah.
The pressures are not, you can just throw those away.
Yeah, okay, so D and A is out.
It's not falling, so.
Which one is it, Mr. Harris?
On the rise.
Everybody says C.
Close on rise and heat to energize the fan.
Yeah.
Yes. That would be like your little fan limit. As it heats, it turns, and when it turns to the fan switch, the fan comes on.
Okay.
Cause this is temperature. This old school on the 60s, but there may be some out there.
I think, what must be done before an ohm meter can be used, really?
Turn off the power.
De-energize the circuit.
That's it.
But your meters are automatic. They won't do it. When we started, you gonna blow that little fuse inside your meter. And it was a little glass fuse, and you had to drive a low meter.
Oh, yeah, two of the same answer, didn't it?
Yeah. You must have had a flute.
I did.
I still got my.
Now, you know the first thing I did on my meter? I put it in amps, not for a clamp, but in line, not knowing, so what do? I put it from line 1 to line 2. And I heard a boom, smoke comes out of my meter, first time I used it. And fortunately, it blew the one fuse that was, it actually blew both fuses in there, even though it was only one.